Okay, this is lesson 11.5 where we're talking about similar figures. So similar figures, figures that have the same shape but not necessarily the same size, are called similar figures. So triangle ABC is similar to triangle DEF. Now when it says same shape, it doesn't mean, well, they're both triangles. They have to have the same angles here. So two figures are similar when corresponding side lengths are proportional and corresponding angles are congruent. And then it's got some symbols there, and it shows AB over DE, that's a ratio, equals BC over EF. So now we've made a proportion because we have two ratios set equal to each other, and that also equals AC over DF. The side lengths are proportional. That little squiggly line means is similar to. It says over on the side. The angles, angle A is congruent to angle D. Remember, that means they're the equal measure. Angle B is congruent to angle E, and angle C is congruent to angle F. And then finally it says triangle ABC is similar to triangle DEF. Example 1. Identifying similar figures. Which rectangle is similar to rectangle A? Well, it's either going to be B or C, and each figure is a rectangle, so corresponding angles are all congruent because they're all 90 degrees. So now we have to check to see if corresponding side lengths are proportional. So let's look for triangle A and B, see if they're similar. The length of A is 6. The length of B is 6, so the corresponding lengths on each of those triangles. That would give us a ratio that was equal to 1. Width of A is 3, and the width of B is 2, so that would be 3 over 2. Now those side lengths, the ratios of the side lengths are not proportional. 1 does not equal 3 over 2. Let's try rectangles A and C. The length of A over the length of C, so 6 over 4, which equals 3 over 2. The width of A, which is 3, over the width of C, which is 2, 3 over 2. So the corresponding side lengths are proportional. 3 over 2 equals 3 over 2. So they are proportional, therefore rectangle C is similar to rectangle A. Now, on your own, rectangle D, they're adding another one, is 3 units long and 1 unit wide. Which rectangle would that be similar to? Do that one on your own. For example 2, finding an unknown measure in similar triangles. So they're telling us the triangles are similar. Now we have to find what x is equal to. Because the triangles are similar, corresponding side lengths are proportional. So we write and solve a proportion. 6 over 9, those are the corresponding side lengths. We're writing them as a ratio, 6 over 9, equals 8 over x. So now we have to make sure that we're putting the measurement for the small triangle on top, 6, and the measurement for the big angle or big triangle on bottom, 9. We have to do the same thing for the second ratio. 8 being the measurement from the small triangle goes on top, and x, the measurement from the large triangle, goes on the bottom. I remember to always put the smaller figure on top, and that way I never have to think about which one did I put on top again. So 6 over 9 equals 8 over x. We could do cross products there, and 6x equals 72. X has to equal 12, so 12 meters. There are 2 for you to do on the bottom here. Remember, put the smaller triangles, or smaller shapes, I should say, lengths on the top of the ratios, and then your proportion should line up just fine.